Okay, Olivia can't hear me. Oh, that's a bummer, Olivia. Sorry that we're missing you, Olivia. Okay, let's go ahead and get started. We were having lots and lots of fun on Monday, right? With all of our crazy theorems and all that good stuff. I hope you guys, everybody can see my screen, right? Move the chat over here. Got that. Voila, here's the notes. Exciting stuff. Okay, so what we talked about Monday is we talked about algebraic properties of equality. So we kind of filled in the blanks for all these different things. And we talked about basically using these properties to prove why we're able to do algebra problems. And then we talked about properties of equality that we could use when it comes to geometry. So let's kind of start there and we'll work our way through some problems. Okay, this is where I got into problems last time, so hopefully my computer is behaving. Okay, good. Last hour, my computer shut down. It was not good. All right, so we have these properties of equality that apply now not just to these are the ones that apply to geometry, right? We were talking about algebraic properties, so we're going to talk about properties of equality that have to do with segments and they have to do with angles. Okay, segments and angles. And I think you guys have these all filled in, but just to kind of review everything. So for any segment AB, the reflexive property says that AB equals AB. Okay, and so when you have an angle for any angle A, I should use my pen, the measure of angle A equals the measure of angle A. So this reflexive property basically just says that, I mean, if you think of the word reflect, they're equal to each other. If you have AB, it's equal to AB. If you have an angle A, it's equal to angle A. That's a pretty basic one, and we don't actually use that one a whole lot, but we kind of start out with that. And then we have the symmetric property. So this one we do use a little bit more. If you think about symmetry, like just the word symmetry, right, or something that's symmetrical, that means that when it reflects across the mirror, it's equal either way. So for our symmetric property, it says if we have line AB equals line CD, then we also know that line CD equals line AB. Okay, so I think that also makes sense, right? For angles, if measure of angle A equals the measure of angle B, then we also know that the measure of angle B equals the measure of angle A. They're symmetric, right? If they equal each other, then it doesn't matter which way that they're equal to each other. And then the third property that's helpful to us is the transitive property. So this is kind of reminds me of the law of syllogism, if you remember this. So this says if AB equals CD and CD equals EF, then because this and this are the same, right? They're reflective across to each other. Then we can say that AB equals EF. Same property applies to angles. If measure of angle A equals the measure of angle B, measure of angle B equals the measure of angle C, then we can say that the measure of angle A equals the measure of angle C. So I think that we talked about all these on Monday, but just to kind of, you know, pull it back together, I just want to make sure that we all have our properties marked down. So why do we learn these properties and how are we going to use them? Well, we are going to use these properties to basically to prove why we can solve certain problems. All right, so we're going to be starting something called proofs. Sounds fun, right? So let's go to example number 3 here. So this kind of gives you a framework of the type of work that we'll be working on in this section. So it says, use the information at the right to find the measure of angle 1. All right, so we have three pieces of information that are given. We have the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals 360 degrees. Okay. We know that the measure of angle 2 plus the measure of angle 3 equals the measure of angle 4. And we know that the measure of angle 1 is equal to the measure of angle 4. That's like a whole lot of measures of angles, right? So what we're going to try to do is we want to find the measure of angle 1 based off of all this information that we know. So you'll see here that what they've actually done, what we're going to do eventually, but what they've done is they've given you the steps as to why that they can do each of these steps. So the first thing is given. We know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 is 360, if I can write a 6, 360 degrees. Okay, that's given to us in the problem. We know that the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle 4. And we know that the measure of angle 1 is equal to the measure of angle 4. Okay, so now we're going to use the substitution property of equality. So if you go back one page on your notes, this is what we talked about on Monday. The substitution property says that A can be substituted for B. If A equals B, A can be substituted for B in any equation or expression. Okay, so we are going to substitute what we know into the equation. All right, so we know this, we're going to take this first equation, okay, and we're going to use the substitution property of equality to kind of substitute what we know. So we know that the measure of angle 1, right here, right, is equal to the measure of angle 4. So instead of the measure of angle 1 in my equation, I'm going to write the measure of angle 4. I'm going to substitute one measure of the angle for the other measure of the angle. So I'm using this given, the third given down here, using this, and I'm substituting it into my first given. And I'm allowed to do that because of the substitution property of equality. Okay. I'm actually going to make another substitution because I know that the measure of angle 2 plus the measure of angle 3, so these guys right here, also equal the measure of angle 4. So for the measure of angle 2 plus the measure of angle 3, I am going to put in the measure of angle 4. Okay. And then I'm going to leave my last guy alone. So measure of angle 4, I'm just going to leave him alone, measure of angle 4. Okay. So now we're going to do, our next step is we're going to simplify, right? So what is the measure of, I realize I can't see the chat. Sorry, guys, if you've been chatting to me. Oh, no, I missed anything. All right, so what is the measure of angle 4 plus the measure of angle 4 plus the measure of angle 4? That's just 3 times the measure of angle 4, right? And we're allowed to do that because we can just simplify. So we just say simplify. So now what are we going to do to solve for the measure of angle 4? The measure of angle 4, we're going to divide both sides by 3, right? And we can divide both sides by 3 because of the division property of equality. So that's why we're allowed to divide both sides by 3. And we get that the measure of angle 4 is 120 degrees. But we're not there yet because what we're trying to do is we're trying to find the measure of angle 1. What do we know though? We know that the measure of angle 1 is equal to the measure of angle 4, right? That's given way up here at the top. So because the measure of angle 4 is 120 degrees, and we know that the measure of angle 1 equals the measure of angle 4, which is 120 degrees, we can say that the measure of angle 1 is 120 degrees by the transitive property of equality. So this is the one that says basically measure of angle 1 equals the measure of angle 4, and the measure of angle 4 equals 120 degrees. So therefore, the measure of angle 1 is 120 degrees because these two equal each other. All right, so what did you guys think of that? It's fun, right? Not only do you get to do the math, you get to prove why you get to do the math. Ooh, I got it easy peasy. It's kind of a different way of doing it, right? So let's do another one. How does that sound? Sounds like fun, right? All right. Okay, in the diagram at the right, B is the midpoint of line segment AC, and C is the midpoint of BD. Show that AB equals CD. Okay, so we got a little bit of work to do here, right? So first thing we start off when we write a proof, and usually proofs are written like this. You've got your steps, and then you've got your reasons on the other side. I'm going to go back a little bit and do something here. I'm going to write it up a little bit higher here. Okay. All right, so what have they given us? We have B is the midpoint if I can get my pen to write, midpoint of AC. Okay, and that is given to us, right? That's given to us by the problem. We also have that C is the midpoint of BD. Also given to us. I'm totally going to run out of room. Okay, so it should be nice and laid out. This is not very pretty. All right, so that's all the information we basically have to go on. B is the midpoint of AC, and C is the midpoint of line BD. But we have a little bit more information than that because we have learned what the definition of the midpoint is. Okay. So the definition of the midpoint says that if B is the midpoint of AC, we know that AB equals BC, right? And that's by the definition of a midpoint. So remember when we learned about, I think it was back in chapter 1, definition of the midpoint. Okay. We also know that BC is equal to CD, and that is by the definition of midpoint. Okay. Everybody okay so far? Okay, so now what do you notice we have? We're trying to show that AB equals CD, right? right here we have AB equals BC and BC equals CD. These two are equal to each other, right? And we have a property that says we can say that AB equals CD because of the transitive property, right? Sorry for the messy writing. Because AB equals BC and BC equals CD, then we can therefore conclude that AB equals CD by the transitive property. And we've shown that AB equals CD. Okay. So I'm just going to let me look at your homework here real fast, make sure that we've covered everything. Lots of fun, right? Loads of fun. Geometry rocks. There's a lot of writing, right? All right. So I think you have enough to everything, but if you there's a couple examples in there. Okay, so let's keep going. You can't hear. Maybe I just wasn't talking. Sorry. I was looking through your book to make sure. Okay, good. Oh, maybe there was an issue with my computer. Sorry about that. You didn't miss anything. All right, so we're going to start on 2-6. Oh, my computer got mad at me. All right, we're going to talk about 2-6. So we're kind of building up to this point. It's so exciting. We're going to start doing proofs in geometry. Don't get too excited. Yes. Proofs in geometry. Okay, so a proof is that a logical argument that shows a statement is true. So if you want to fill this in your notes, a logical argument that shows a statement is true. Okay, so actually you started doing proofs without even realizing it because we just did 2 proofs right on the other side of the car, or the other side of the car, I don't even know what I'm talking about. We just did 2 proofs about 5 minutes ago. All right. So there's several formats for proofs, but the most popular format for a proof is called a 2-column proof, which is what I just showed you up there, right? So you're going to have 2 columns. Basically, you're going to have your work over here. Okay. And then you're going to have the reasons or the arguments over here. Oh, it's not even letting me write. Reasons is what that's supposed to say. Let's just erase that because I can't even see that. So yeah, you're going to have your work. There we go. Work. and you're going to have your arguments over here. So this is your why that you're able to say that this is true. Okay. Yes, so that's what's going on with that. Okay. The other thing that we're going to talk about is a theorem. So we kind of had an introduction to this, and you have your paper there, and we have our first two theorems here. So the reasons used in the proof can include, so when you have your work over here, this is just what you standard do, when you're solving a problem, you do the work. When you have your arguments over here, the things that you can use to prove that your proof is true, okay, include definitions, right? I'm going to switch to typing because this is not working well. So when you're giving your argument, you can use definitions. You can use properties. You can use postulates. And we can use these things called theorems. I spell it right. Okay. And I think we've talked about a little bit what theorems are, but theorems are actually something that has been proven. And then once you prove that a theorem is true, then you can use that theorem to reason that other proofs are true. So it's not something like a definition, right, or a property or a postulate or things that we've just come to accept as true. Theorems are a little bit different because we can actually prove them. But then once we've proved them, then we can use them to prove other things. All right, it's like double proving something. Okay. So let's talk about our first few theorems here and what they are. And I don't know why they're in out of order. The other thing I want to make sure you guys are doing is pull out your theorem sheet, right? And you not only want to take these in your notes, you want to put them on your theorem reference sheet. Okay. All right, so theorem 2.1 is the properties of segment congruence. All right, so if you just think about what we talked about a little bit before, we talked about the properties of equality. And now we're talking about congruence. Remember how congruence and equality are a little bit different? So congruence feels like the same thing as being equal, but it's different in the terms of the geometry world. Okay, so we're talking about congruence versus just equality. But these properties kind of remain the same. So for any segment AB, okay, line AB, oh, I need to type it out, sorry. Line AB is congruent. I can't get my pen to work right. I'm sorry, guys. To line B. No, line AB. And that's really messy looking. I'm going to try to write this over here. So you might be saying, didn't we just do this? Feels like what we just talked about, right? But it's the difference, and the difference from the equality properties is we're talking about congruence now of our segments, okay? So the properties of, that we have one sheet back where we said for any line segment AB, AB equals AB, okay? We're talking about equality for that. For these particular theorems, we're talking about congruence. So when it comes to congruence, we actually have to prove that it's true via a theorem. When it talks about equality, it's just a property that we all accept. So that's why we have these two different definitions. Okay. Everybody following? I know it's blurry. I got to figure out how to type this better. So reflexive should say, this is what it should look like. It should say A, B, okay? But we're not talking about our line segments. We're actually talking about, or we're not talking about our lines, we're talking about our line segments. So it should actually say line AB is congruent to line AB for our reflexive property. So reflexive means the same thing across all the different properties of theorems, but it's just a little bit different. For how we would do that. Okay. Is it less blurry now? Okay. So then for the symmetric property of segment congruence, if you have line AB is congruent to line CD, then we know, I'm going to write this over here, that line CD is congruent to line AB. And I got to fill in my blanks here. You got line, line, and you have the little congruent symbol over here. It's the little fancy congruence. Should have this congruent symbol there. Okay, and then the transitive property, if we have line AB is congruent to line CD and line CD is congruent to line EF, then, see if I can write it out. Line AB is congruent to line EF. There we go. I just have to write it bigger. All right. Now for any angle A, okay? Angle A is congruent to angle A. If angle A is congruent to angle B, then angle B is congruent to angle A. And if A is congruent to B, angle A is congruent to angle B, and angle B is congruent to angle C, then angle A is congruent to angle C. So all these properties kind of keep repeating themselves, but now we actually have congruence properties, and these are in the form of a theorem because they're not just accepted, they can be proven. So let's pick one of these and actually prove why it's true. It's not exciting. It's not extremely exciting, but let's pick one and prove that it's true. Okay. So let's pick the symmetric property of angle congruence. So let's actually prove that this is true. Does that sound fun? Sure, right? Why not? Okay, so the symmetric property of angle congruence basically says that if we have angle A is congruent to angle B, so this is what's given, right? Then we can say that angle B is congruent to angle A. So this is basically what's given, and this is what we want to prove. So we are going to make a proof. Okay, so we always start off, when you make a proof, you start off with what's given. I know that angle A is congruent to angle B. Okay. One of the things that's helpful, you don't have to do it, but it's very, very helpful, is that we can always draw a little diagram off to the side to kind of help us. So I know that angle A, right, is congruent to angle B. And my reason that I can say angle A is congruent to angle B is that it is given. All right. So now, what else do I know just based off of angle A is congruent to angle B? What do I know is true? Well, I know what the definition of a congruent angle is, right? Or at least we learned what the definition of a congruent angle. So the definition of a congruent angle says that the measure of angle A is equal to the measure of angle B. I know that in your head, they seem the same, but they mean two different things, right? This is congruence and this is equality. And I can say that the measure of angle A is equal to the measure of angle B because, and I'm going to type this, because of the definition of congruent angles. Okay, so by definition, if two angles are congruent, then the measure of the first angle is equal to the measure of the second angle. Okay, and so then I can say, because I have this property that we learned back one section ago, I have this property called the symmetric property of equality, right? I can say that if the measure of angle A equals the measure of angle B, then the measure, no, that's not what I was trying to do. The measure of angle B equals the measure of angle A. And this is just right from the section that we just did, that we just started off talking about. And this is because of the symmetric property of equality. This is what we started off the day with, right? Reviewing our properties of equalities for lengths. All right. Now I have the measure of angle B equals the measure of angle A, but I need to prove that angle B is congruent to angle A. So I'm going to convert this back into a congruent statement and say that, I keep forgetting to do that, and say that angle B is congruent to angle A. And I can use the same property that I did before. I can say that because the definition of congruent angles. All right, so now I have proved that theorem, what is it? Theorem 2.2 for the symmetric angles is true. That was pretty exciting, right? So by saying that now I have theorem 2.2 that covers this, I don't have to go back and every time that I want to say that angle A is congruent to angle B, so angle B is congruent to angle A, I don't have to do that every time because now I can just say I've already proved it in theorem 2.2. Hooray. Okay, any questions about that? So now we're able to use all these theorems in order to make another argument for why certain things are true. Does this make sense? Are you guys like, what is going on? Everybody still here? All right, I got 1 makes sense. All right, 2. That's good. That's good. Awesome. All right, so let's do some more proofs. So 2.6, you're going to be practicing lots of proofs. So this is where you're going to want to pay attention, go back and pay attention to all your different definitions and properties and now these theorems that we have. We're going to kind of pull them all together. All right, so we're going to prove another one of our theorems, okay? So this theorem 2.1, our transitive property, right? The transitive property says if AB is congruent to CD and CD is congruent to EF, then basically AB is congruent to EF. So let's go ahead and prove another one of our theorems, and that just gives us more practice in doing proofs. So you can see they have a little proof listed out here for you. So we have a framework to work in. Okay. So basically, we're proving that this is true. We're proving that this part of theorem 2.1 is true. So you can prove the transitive property of segment congruence as follows. So we're given that JK is congruent to MN. So JK right here is congruent to MN. And MN is congruent to PQ. And we want to prove that JK is congruent to QP. All right, so if you're ever doing a test or homework, you should at least always get the first line of the proof right, because the first line of the proof is always just taking what you're given, you write it down as a statement, and you say the reason that you can say this is true is because it is given. So you should at least get points every single time for writing down what you're given, and the reason that you can write it down is that it's given. All right, so that's good. All right, so then we have JK is congruent to MN and MN is congruent to PQ. Okay, so next up we want to say that JK is equal to MN and MN is equal to PQ. So can you see when we go from step 1 to step 2, we're going from a statement of congruence to the statement of equality. We're not talking about congruence anymore, we're talking about equality, right? Why are we able to say that if 2 line segments are congruent, they're also equal to each other? We're able to say that because of the definition of congruent segments. Right? So if you go way back to our definition of congruent segments, that's what I was trying to find here real fast. See if I can find it. It's probably in the back of your book. I don't even look. Do they have all the definitions back there? Got all the postulates back there. I'm trying to read it off to you. So the definition of congruent segments are line segments have the same length. All right, so we can say that because they're congruent, we also can say that the line segments are equal, and that's due to the definition of congruent segments. So now that we have JK equals MN and MN equals PQ, we can use the transitive property of equality. So what's the transitive property of equality? You go back into your notes, scroll back a page, and the transitive property of equality says if AB equals CD and CD equals EF, then AB equals EF. So this is a property. We don't have to prove it. We can just use it, right? So because of that, we can say that JK equals PQ. Right? But we're not quite there yet. We have JK equals PQ, right? But we're just talking about equality and not congruence. So now, if we use the definition of congruent segments again, we can convert the fact that JK equals PQ into that line JK is congruent to line PQ. And we've proved that to be true. A lot of the times what they're asking you to prove is easy, and it's more in the steps of how to prove it that you kind of learn how that all works. All right, so now we're actually going to do another proof. Shocker, we're going to do lots of proofs. We're going to do another proof, but this time our proof is actually going to use these theorems that we just learned. Okay, let me pull that up. I know. By the end of geometry, you're going to be nice. You're going to be awesome at proofs. Okay, so use the diagram. So they give you a picture and the given information to complete the proof. Okay, so what we have is that PQ is congruent to RS. PQ is congruent to RS. So basically the top and the bottom line. PQ is congruent to QR. And PS is congruent to RS. So we have a lot of given statements here, right? A lot of line segments that are congruent to each other. And we want to prove that PS is congruent to QR. Okay, that's a whole lot of letters, P, Q, R, and S, right? So we start off, you should always get credit. We know that PQ is congruent to RS. That's given right here, right? And we write down given. We also know that PQ is congruent to QR. Guess what? In this particular problem, you should get more than one right because you're going to get them all right because you're smart. But we have lots of givens, right? This is one of our second statements that's given. Okay. Now, we are actually going to use that theorem that we just learned. We're going to say because PQ is congruent to RS and PQ is congruent to QR, we can basically conclude that since these two are, always do that. All right. We can conclude since these two are equal to each other, that RS is congruent to QR. Okay, and we can conclude that because of the transitive property of congruence, or theorem 2.1. So remember before we would have had to convert this to equality and use our properties, but because we have this theorem that says we can use the transitive property of congruence for congruent segments in theorem 2.1, then we can just use that without having to prove it every time. So it's like kind of a shortcut to our steps, right? All right, so now we have line RS is congruent to line segment QR. Now we have PS is congruent to RS. So we're going back to our given statements and we're putting another piece of information in here. So this is also given to us, right? So since they gave us 3 pieces of information, we should have 3 given pieces here. All right, and now if you look at these two, we have an RS here and an RS here. So because, again, of our transitive property of congruence, we can say that PS is congruent to QR. Or, again, using theorem 2.1. Okay. So that's that. That is 2.6. There are 2 more examples, but I would like to save those for Monday so we can, I mean, they're a little bit more complex of proofs. So I think you should definitely be able to tackle 2.5. We finish that up, and you could probably try the first few in 2.6, and if it starts to get complicated, don't stress out too much. We will do more on Monday from 2.6. Okay? Nice. Yep. So thank you guys. Have an awesome day. I will see you guys on Monday. Text me if you guys have any questions or send me email, whatever works. All right. Thanks, guys.